Now that we have our data in our array, let's say we want to sort that data so that it's maybe decreasing to increasing or just going alphabetical order or something like that. So how do we sort? Well, I'm going to show you a basic selection sort. So right now if we run this, we have a bunch of data and it's all out of whack. And I'm actually going to modify it a little even more, and we'll say that. So if we rerun it, there we go, there's our data. So if we want to sort this, I'm going to use a selection sort. There are plenty of other sorts online. This is the one that I know best. So we need to create a for loop, just like that. And we're going to make it go to nums.length minus 1. And I'll explain everything as much as I can. So I'll come back to why we need to say nums.length minus 1. Then we need to create another for loop. And so this is called a nested for loop. We have a nested for loop, or a for loop inside of a for loop. Then typically we go from I to j. J is the next value. And we're going to say j equals I, just like that. Now, what a selection sort does is if we have some values, I'm just going to list out some values. So we'll say like 4, 6, 3, 9, 7, 5, like that. Now let's say we want to sort these. When we use a selection sort, we start with pointing at the first value. And we say, okay, so right now 4 is the only number I've looked at. And that means it's the smallest one I've seen so far. So 4 is our min. Then we look at the next number. 6 is not less than the min, which is 4, so we move on. 3 is less than the min, which is 4. So now 3 becomes our new min. And let me make sure this is filled. I don't know why that didn't work. Okay. Now 3 is our new min instead of 4. Then we compare 9 to 3, and 9 is greater than 3, so we move on. 7 is greater than 3, and 5 is greater than 3. So we're going to take 3, which is our min, and we're going to swap it with the first value in our list. So now our new list becomes 3, 6, 4, 9, 7, 5. Okay, now we know 3 is the smallest value in this list, so we're going to start with 6 as our min. So now we're looking for the second smallest number. Then we compare that with 4, and 4 is smaller. So 4 becomes our new min. And then 9, that's still greater than 4, 7 is greater than 4, and 5 is greater than 4. So we swap these two. We swap the min, which with whatever the next value is. So our new list becomes 3, 4, 6, 9, 7, 5. Like that. And then we set 6 again to be our min, because that's the next value. We know 3 and 4 are in the correct spots. And then we check, is 9 less than 6? No. Is 7 less than 6? No. Is 5 less than 6? Yes. So now we swap these. Like that. Then we have 3, 4, 5, 9, 7, 6. Okay. Now 9 is our min. Just like that. 7, that is less than 9, so 7 becomes our min. And I realize I forgot to do that on here. Let me quickly fix that. That's our min. And then 6, that's less than 7, so now 6 becomes our min. And now we swap 6 and 9. Just like that. So our new list is 3, 4, 5, 6, 7, 9. Now, of course, looking at this, we know this is done, but the computer doesn't know that. 7 might be greater than 9, so it still needs to check. So 7 becomes our min. And then it looks at 9, and it says, okay, 9 is greater than 7, so 7 is still our min. So it'll actually swap 7 with itself. But, of course, that does nothing. And now it knows that the list is done, because 9 has to be in the correct spot, because there's nothing left. Once we write out the new list here, there's nothing else left for 9 to compare itself to, except for itself. So this is our sorted list here. So how do we write that in code? Well, we have the beginning of it started. So when we go back here, I represents this first arrow here. This is what's getting swapped. So here it was 4, here it's 6, here it's 6 again, here it was 9, and then here it would have been 7 if 7 needed to be swapped. So we go back here, and then J represents this arrow, these arrows here, looking through the rest of the numbers in the list or the array. So the arrow always starts here, or even the next number as well, depending on how you set it up. So we can actually say J is equal to I plus 1. And when we go back here, the arrow does go to the end of the list every time. We need to check all the values, which is why J still goes to nums.length, whereas I only goes to nums.length minus 1. So we need to make a min value to keep track of the minimum value. So we're going to say, and actually we don't want to store the min value, we want to store the index of the min value. We want to keep track of where it's located. You can keep track of both, but I'm going to do int min index, and we're going to set it to I. So this is going back to this. We're assuming that the first number we look at is the min, right? We always set this first value as the minimum value. Then we go in here, and we need to check if nums at j is less than nums at min index. That means if we're looking at a number that's actually smaller than the number that's storing the min, that means the min isn't actually the min, so we need to fix it. So if that is true, then j becomes the new min. So the min index actually stores this j value now. And then it's going to keep going, keep looping through here until it finds a new minimum value. Now, once this for loop is done, right here, that means we've checked all the values, we've gone through, our arrow has pointed to every value, and we're guaranteed to have found the next minimum number. So all that's left to do is to swap. So how do we swap? Well, let's say you have 2 markers in your hands, or you're just holding 2 things in general, one in each hand, and you can only hold 1 thing in each hand. You can't hold 2 items. So how do you swap the items in your hands? Well, you need to put one of them down on a table or something like that. Then you can swap over the item that's in your other hand, and then pick up the item with the hand that you just let go of, or that you swapped from. So now you've swapped the 2 items in your hands, but you needed a third value. We call that a temp value. So our temp value is going to store whatever data type our array is. In this case, we're storing ints, so it needs to be an int. Int temp, and then pick one, either min index or I. It doesn't matter. We'll say nums at I. So we're going to take this value and store it in the temp. Then we're going to take nums at I and store nums at min index. Then we're going to take nums at min index and replace that with the temp value. So this is a generic swap. This is how you swap values in Java. So now our list should be sorted. I'm going to do a quick for each loop. Oops. My bad. Is this out? I. Not you. I. Alright. So it should print out the original list that we had, as well as the sorted list. And I'm going to put a quick line in between so that we know where is where. Okay, great. Now everything is sorted. So that's the basis of a selection sort. And there are plenty of different sorts out there. Some are much better than others, such as insertion and selection are both pretty good sorts. A bubble sort is pretty bad, don't use it. Then you have more complex sorts like merge sort, quick sort, radix sort, but don't worry about those too much for right now. Those are a lot more complex. If you are interested, I think radix sort is the easiest of those, because the other two require something called recursion, which is a very advanced topic that I'm not going to talk about for quite a while probably. But radix is a very quick sort that it's pretty easy to understand. At least maybe not the way it works. It's sort of like magic how it works. It's pretty cool. But it's a lot easier to implement than the other two sorts. So that's the basis of sorting. But what if we want to sort strings? Well, I'm going to talk about that in the next video. We're going to go over something called the ASCII table and chars and everything like that.